Tim Shaver is the soil specialist located at North Platte, put this presentation together, and then I've modified it some. How many essential nutrients are there for plant growth? 16. What are the three largest used nutrients? Does anybody? Okay. That's exactly the response I would expect. I tend to think of in terms of what we worry about in terms of managing the crop, but the nutrients the plant actually needs, we don't have to provide. They come from air and water. So carbon, hydrogen, and oxygen compose the majority of what plants use in terms of nutrients. And then N, P, and K are the fertility nutrients that we think about in terms of managing. About a decade ago, we published the book Nutrient Management for Agronomic Crops in Nebraska. It's out of print now, and unfortunately, we have a policy where after certain publications get so dated, we dispose of them. And we disposed of the last printed copies that we had here this last winter. So it's unfortunate. Much of it was still a valid publication, but it is available online as a free PDF. So if you go to CropWatch, if you've heard of the CropWatch website with the university, and then the soil management website or tab with that, you can download and access this publication electronically. And it contains much of what we've been talking about today, and then also a section on management of nutrients for crop production in the state. So there are 16 essential nutrients. We tend to think of the macronutrients as nitrogen, phosphorus, potassium. Secondary nutrients, calcium, sulfur, magnesium. And then micronutrients, these other 7, 8 or so. Not in terms of their essentiality to plant growth. All of them are equally essential. If we're missing one of these nutrients, we are not going to have plant growth. It's just related to how much of the nutrient is actually required in the plant to grow. We're very blessed here in Nebraska to have soils that are highly fertile. Why is that? Have we talked about that yet? What makes Nebraska different from North Carolina, for example?
Freezing and thawing.
What's that?
The freezing and thawing.
Freezing and thawing. That sure helps. Yeah. Parent material. Glacial deposits. Depends where you are in the state, and depends how you define glacial deposits, I guess. But yes, I don't know whether North Carolina was glaciated much or not. But right here has been glaciated, but once we go very far west in Nebraska, that's not been. But glacial deposition, if we think of dust following glaciers or loess deposition, that's a major component to our soils in Nebraska.
Hey, Richard, the other main thing is that most of Nebraska's soils were formed under prairie ecosystems.
Okay.
And those prairies produce a lot more organic matter, root mass, and all of that, and recycles, and so just over time, that leads to a more fertile soil.
That's right.
Climate is the other.
Okay. So what about that then, Mike?
Well, if you think I had those samples, I had one from North Carolina. What's the difference between North Carolina versus Nebraska?
And now I'm asking that question too.
More
So
rainfall, more temperature.
okay.
So it's mineralized the soil much more.
So in terms of how we would define or call a soil, things that have been through more rain, more temperature, for more time, we tend to call older soils, more weathered soils. So our soils in Nebraska generally are younger and less weathered than some soils as we go farther east. And consequently, the nutrients that they've lost on those more weathered soils, we still have. So consequently, we don't need usually potassium on our soils, for example, here in Nebraska as a nutrient. Whereas you go farther and farther east, they need more and more potassium because That is a nutrient that has been leached out over time. I'll see how far I go. I'm starting into your lunch hour, so I'll need to look for a good place to stop here. I've got another 50 or 60 slides, and I don't think that'll work. Tim put this together, and he wanted to be sure he included everything we might need, so it's there. In terms of plant uptake, there are 3 methods of how these nutrients get into the plant. We've listed those here. Mass flow basically is, as you can picture it, as water is flowing along, it just carries nutrients with it. And so nitrogen, sulfur are the 2 nutrients, particularly in Nebraska, calcium and magnesium to some degree, also are primarily taken up via mass flow. Just as water is going into the plant through the process of transpiration, that carries these nutrients with it. Diffusion occurs primarily where roots are close to a source of nutrients, and there is uptake of a nutrient, creating a diffusion gradient so that a nutrient will diffuse over that short space to access the root and be taken up into the plant. Potassium and phosphorus, for example, are taken up primarily through the process of diffusion. Root interception then is the process where a root just happens to run into a location where there are nutrients available. And that can apply to any of the nutrients, but particularly those that are less mobile. So phosphorus and potassium, for example, iron, root interception can be a significant mechanism for uptake. But primarily either mass flow or diffusion are the methods by which nutrients enter the plant. Now, in terms of crop production in Nebraska, nitrogen is the nutrient that is most often limiting and the fertilizer that is used in largest amounts in the state. It's not for a lack of nitrogen, it's a lack of the form, or a difference in the form. So we're surrounded by nitrogen as we breathe. Most of what we're breathing is nitrogen gas, but that's not in a fixed form that's plant available. So it has to be converted into a form that the plants can use. There are a number of processes by which that occurs, several naturally. John talked about the Haber-Bosch process. That was the first really significant commercial process by which nitrogen could be converted into a form that is fixed for plant use. But much of that fixation occurred primarily earlier by legumes. So before we had commercial fertilizers, we relied on crop rotations with the legumes to provide fertilizer for those species that did not fix fertilizer. There are species in soils that do fix nitrogen as well. Some algae and fungal species that are non-symbiotic that can fix in. Lightning. Every year there's, in Nebraska, probably 10 to 20 pounds of N that's deposited from rainfall with fixation that occurs via lightning and rainstorms. And then finally, synthetic manufacture. And what we're ending up with, ultimately, are these 2 forms. Either ammonium or nitrate are the 2 forms that plants use in their metabolic processes. There's been, Mike alluded to, and I think others have as well, these various loss mechanisms. The nitrogen cycle, I'm sure you've all studied and been exposed to. It's something that impacts Nebraska on a daily basis, farmers on a daily basis. They don't think about it, needing to think today, well, how am I going to manage the nitrogen cycle? But as we are producing crops in the state of Nebraska, there are various aspects to the end cycle that influence how the fertilizers that are used by those crops are used by the crop or lost to the atmosphere or to groundwater, to runoff. There's 4 or 5 loss mechanisms that really impact fertilizer management for crops here in the state.